Here I am live on the Pegasus Barge, which is used to transport rocket boosters from NASA Michoud, which is Rocket City, USA, to the Stennis testing facility, and then onto Kennedy Space Center. Back here, I'm going to try and adjust the contrast. You can see the glowing behind me, and that's the end of a tunnel. I'm going to change the... And now you can see how far down it is. It's 160 feet long. And you'll see videos that I'll be uploading later with a lot of the different NASA engineers and the NASA, I would call them the Admiralty, but the people that are in charge of crewing this barge. They have 5 full-time crew and 1 NASA representative on board when they take their trips to and from Stennis and Kennedy Space Center, as well as a couple of other unique places that they've transported different rockets to be housed after their use or testing. But check out the length of this baby. It was actually expanded in order to accommodate the SR-25 rockets, the SLS systems. And you can see a line there in the floor where the floor was welded back together. It's held up by booster tanks, or ballast tanks, I'm sorry, that are underneath that allow for different equilibration as the load comes on down at the far end. And the really neat thing I thought, and I'll show pictures of it later, they have upraised lit platforms that are in the shape of semicircles that the large doors, as they close, they have rollers that go over them, and there's a rubber gasket there that creates a watertight seal so no water gets onto the stage.
Coast Guard licensed mariners. I've been a boat captain since I was 19, and I'm old, so I've been doing it.
How long have you been at NASA?
So I've been here for 10 years.
And was this kind of like a capstone to your career? Was this something you always wanted to do, or did it just kind of fall in your lap?
It kind of fell in my lap. It was just one of those things that just happened to come along, and I had the opportunity and came out here, and I actually loaded ET tanks on this barge right here on Pegasus.
Wow.
What is this height clearance?
Actually 27 ballast tanks, but there's 26 tanks that we use for controlling the trim, the list, and the draft of the vessel. If we pump up every tank on this barge, we'll have 1,400,000 gallons of water on board, and still we'll be at a 13-foot draft. But he was talking earlier about when we load on here, it's close to 800,000 pounds. So as that weight is coming on, we have to take weight off by pumping water off. When we offload the core stage, then we have to do the opposite. As it's going off, we have to add water on to keep weight on the barge so the barge doesn't pop up once the core stage.
That's actively done as you're offloading and unloading?
We actively ballast, so we're ballasting as it's coming on, and we're ballasting as it's going on.
How long is that onloading and offloading process?
Usually around about 4 hours or so.
So you got plenty.
So he mentioned that out there. Is this controlled by computers, or is this manual by
it's
humans?
All old school manual.
So yeah,
you'll
one of the
see
few things
you'll
in
see
NASA.
on the deck, if you look right behind you, you see a 7C right there. So that's 7 center tank. There's a sounding tube there, so we actually lower a tape down in there and measure the depth of the water. The ballast controls down in the mechanical space. There's a big, huge manifold system down there. We have 2 pumps that we can run, and we open and close valves. We do it all manually.
Is there any talk of making it sensor driven?
No, not at this point. It is a possibility, but not at this point.
At what speed do you move from Stennis to there? Do you maintain,
Our speed through the water? Generally on our way, when we do a 2-tug configuration, our speed is generally around 5-6 miles an hour. So when we cross the Gulf with the single tug, it's around 6 to 8 miles per hour. And when we go up the Mississippi River, it's around 6 to 8 miles per hour.
so you take the straightest, less curved paths as you go, so this is pretty much like a steady on.
When we cross the Gulf of Mexico, we go out the Gulfport Ship Channel to what's called the sea buoy. We go straight across to the Tortugas, around the Keys, and up the coast of the Cape. Stove, and I mean, we live there, so there's 6 of us that travel on the barge when we travel. So there'll be 5 crew and 1 NASA representative every trip that we make. Here, watch your step coming up here. Be very careful.
Washer, dryer back there. Here's your chore list for the day. Fire extinguisher, which would come in handy in the stand lab lately.
play safety right here.
And lots of really cool buttons that we shouldn't hit.
So if you come around this way, watch your head, watch your step. Come out here on the forward deck. This is the living quarters.
Here we are walking out on the front of the barge. I'm trying really hard not to fall flat on my face and trip. There we go.
Some pelicans around here, and along with pelicans comes, you know what?
Pelican poop.
Pelican poop, that's right.
Everybody poops, it's okay.
Is everybody coming? You got everybody coming behind you there?
Yes, they're coming.
Okay. Now this is the foredeck. We have two 5,000-pound anchors that we can operate with these hydraulic capstans up here. When we tow on inland waters, we use a wire. So we use a wire bridle, what's called a bridle, and a wire hawser, which is the line that they tow us with. So we do three different towing configurations. We do a two-tug towing configurations where we have one tied up on the stern pushing and one out here pulling us. We do a one push tow configuration up the Mississippi River when we go to Marshall Space Flight Center, where we have one large tug that ties up on the stern, and we actually run controls for that tug up into this pilot house, and they can actually control the tug from this pilot house up here. When we cross the Gulf of Mexico to go to the Cape, we do two tugs to the Mississippi Sound, and then we hand off to an ocean-going tug, and we have a 6,000-pound chain bridle hanging on the bow up here. We actually lower that chain bridle down to that tug, and he hooks into it, and then he tows out. He generally tows about 1,400 to 1,500 feet out in front of us when he tows us. So he's a quarter mile or so when he tows us across the Gulf. So
Why is that so far out?
it's for shock load. So the more it's called catenary in the tow makeup, that shock load is absorbed. So with the waves and everything,
Gives you a smooth ride.
gives you a smoother ride. Yep. So I've seen it. See, I've been at South.
With this vessel.
With this vessel, nothing really. Nothing really.
You gotta have a good story.
No. When they transported ET-94, which was the last existing external tank here, to the California Science Center on an open deck barge, they went through the Panama Canal. When they got into the Pacific Ocean, they actually responded to a mayday and saved 4 fishermen. And
While
I always
dragging
think about
this
these
big,
guys
huge
are out there
thing.
in the water, they look up and here's this big huge orange tank coming at them. That was kind of a strange.
How about weather? How do you get ahead
Well,
of weather?
we have parameters that we're allowed to operate in. So we work with Kennedy PS, chart plotter, what's called Rose Point. So we have a lot of the usual navigational equipment you would find on board a ship.
So your route isn't directed necessarily by NASA in real time, it's you directing it here on the ship.
Well, the route is basically determined by the tug contractor and NASA, but yeah, I mean we'll make the call out there if we need to alter course or whatever for weather. So 6 to 7 days. So by the time we leave the dock at Stennis and hit the dock at Kennedy at the VAB there, it's about 6 to 7 days.
And how long does it take you to get back?
Same.
Okay, so you come
Same.
back with the same. You
Yeah.
don't leave it there and then come back.
No, it's